Hi everyone, this is Professor Nancy. Today we are going to be going over solving quadratic-like equations. So thus far we know how to solve quadratic equations by using factoring, completing the square root method, or the quadratic formula. But what happens if you have an equation where the highest exponent is not 2, but it looks something funky monkey? Is there anything that we can do to solve an equation like that? So hold on tight, we're going to do an example that one of your classmates asked. So here in this problem, we see this equation here, which looks kind of funky monkey, right? Whenever we solve a quadratic equation, we want the highest power, the highest power needs to be 2. If the highest exponent is 2, then it's a quadratic equation and we can solve it using our methods of solving quadratic equations. However, when you have something that looks funky monkey like this, what do? So what these are called are quadratic-like equations, meaning we're going to do something to it to make it look like a quadratic. So that's one of the beauties with math, is you can kind of transform or mask something and to make it look like the way that you want it to look like. So we want it to look like something with u squared plus u plus the number is equal to 0, right? Something with a squared in it. So what I'm going to do is I'm going to I'm going to do what we call u substitution. So I'm going to substitute this x here with a u. So here what I'm going to do is I'm going to look at the middle term and I'm going to let u equal to that middle term. And that way, when I replace it, I'm going to end up getting a u instead of an x to the 1/3. So I have u minus 2 is equal to 0. So this becomes u. Now the question is x to the 2/3. What is that? What happens to that? Well, what do you know? Check this out. If I squared this term, if I squared this, x to the 1/3, if I square it, using the power rule of exponents, you multiply the exponents, you end up getting x to the 2/3. So what do you know? X to the 2/3 is the same thing as u squared based on our substitution. So here I substitute and I get 3u squared plus u minus 2 equals to 0. So now this is our new equation using the letter u. So as you can see, this ugly equation ends up looking something really nice and simple temporarily, and we can now solve this because it's a quadratic equation. So because it's a quadratic equation, we're going to ask ourselves, how do we solve this? So I'm going to use factoring. So I'm going to try doing Xbox method. So 3u times u will give me 3u squared. Well, two numbers will give me 2, let's say 2 and 1. So one of them is going to be negative. When I do the x here, cross multiply, I get 3u and 2u. What do I do to make this into a positive 1u? Can I add or subtract it? I sure can. If I subtract negative 2u, I will get u, which gives me that middle term. So therefore, I need a negative right here on the 2. And therefore, negative 2 times 1 does give me negative 2. So there is my xboxing. So when I factor this, this now becomes 3u minus 2 times u plus 1 is equal to 0. And again, now going forward with how do you solve a quadratic is after you factor it, you use a ZPP property, zero product property, where you set each factor equal to 0 and you solve for it. So here we get 3u is equal to 2, so u is equal to 2/3. And here u is equal to negative 1. So now I have solved this problem for u. So I've solved the problem for u. If I plug 2/3 in here, I'll get 0. If I plug negative 1 in here, I get 0. Are we done? No, we're not. Because we're actually asked to solve for x, not for u. So what is x then? If we know our u, can we find out what x is? We sure can. So here I'm going to solve for x. And I ask myself, what is the relationship between u and x? Oh, it's right here. Let u equal to x to the 1/3. So u is equal to x to the 1/3. So we're going to use this. We're going to use that relationship that u equals to x to 1/3 to find what x is. So here I have u is equal to 2/3. So when u is equal to 2/3, when u is equal to 2/3, what is my x? So 2/3 is equal to x to the 1/3. How do I solve for x? Well, I want x to be sitting by itself with the power of 1, right? So to get to that point, I'm going to raise this to the 3rd power, because x 1/3 times 3, if I multiply these two together, I get x to the 1st power. So I have x sitting by itself. And remember, whatever you do to one side, you must do to the other side. So I also raise this to the 3rd power. When I raise this to the 3rd power, 2 to the 3rd is 8. 3 to the 3rd is 27. Ta-da! This is what x is. X is equal to 8/27. Now, don't forget, when u is equal to -1, what do I get for x? So when u is equal to -1, I'm going to plug -1 back into this relationship. So I have -1 is equal to x to the 1/3. And I do what I just did up here. So I'm going to raise this to the 3rd power. I'm going to raise this to the 3rd power. 1/3 times 3 just gives me 1. And then I raise -1 to the 3rd power. -1 to the 3rd power is just -1. So my final answers then are x is equal to 8/27 and also -1. 2 answers. And if you want to check your work, you could plug it back in to make sure that this equals to 0.